Okay, so 2.1 is the first part of some triangle work with trigonometry. And there's a couple things you need to really know to begin with. And that starts on page 56. So, when we look at angles, this is what we call the quadrantal axis. And when we look at angles on this axis, on the quadrantal axis, we always start every angle along the positive x-axis. So we refer to this as our initial arm. Okay, so that's the initial arm. When I move it in a counterclockwise direction, I am moving it such that it becomes a positive angle. So I keep moving it this way, and that is a positive angle. Okay? Greater than 90 degrees, less than 180. This one we call our terminal arm. So our terminal arm is the one that goes around the circle. Alright? Now, when we studied grade 10, when we did trigonometry, we just mostly looked at sine, cos, and tan with right-angled trig. But here what we're going to do is we're going to find angles that we can actually find the correct values for without having to use your calculator. See, in grade 12 math, we spend the majority of that class doing the work without calculators. So is there a way in which I can create trig ratios that I should know? For example, the sine of 30. I should know what the sine of 30 is. It's 0.5. Okay, or 1/2. But then the sine of 30, I should know what the cos of 30 is as well. The cos of 30 is root 3 over 2. So those are just things that we're going to learn as we go along here. And then we end up memorizing it. It's probably the least mathematical thing you do, but memorizing these ratios is what you're going to end up having to do. Okay? So in order for it to be a positive angle, the terminal arm has to go in a counterclockwise direction. Alright? The other thing we often don't know about, or we maybe do and don't, is do we know how to label the quadrants? 1 to 4? Where's quadrant 1? Top right. That's right. Positive, positive. That's where we start. So there's quadrant 1. Here's quadrant 2. Here's quadrant 3. And here's quadrant 4. Okay, those are going to be important to us, so we have to remember those. Alright, I'm going to write this here right now. It will not make any sense to you for probably a week. Maybe not, maybe sooner, but also label it cast. Starting in quadrant 1, C-A-S-T. Okay, you'll understand why when we get going into this. Now, all of the angles for the terminal arm in quadrant 1 are between 0 degrees and 90 degrees. In quadrant 2, my angles become 90 degrees, are in between 90 degrees and 180. In quadrant 3, my angles are 180 to 270 degrees. And in quadrant 4, they're 270 degrees to 360 degrees. So far, okay? One other very, very important piece of information that you want to know is what we're going to refer to as the reference angle. Now, the reference angle is always made with the x-axis, but it's going to be important to us. I did touch on this a bit in applied when we talked about sine angles. The sine of 30, the ratio is 1/2, and the sine of 150, the ratio is 1/2. Okay? So we did touch on that a little bit, but we're going to really go a lot more in depth with this now. So this guy we refer to as the reference angle. So theta r is the reference angle. Okay, so far? So just some terminology to start this off. Just following along here. Any questions so far? All right, so let's go back here. I'm going to jump ahead before I get into the triangle work, and I'm just going to look at example 1 in your book. So example 1, working example on page 57, says sketch each angle in standard position. State the quadrant in which the terminal arm lies. So 80 degrees. Which quadrant is 80 degrees in? Quadrant 1. So to graph it, or to draw it, it would look something like this. Okay? My initial arm always starts here, and it would rotate up to here to get to 80 degrees. What about 120? Which quadrant would it be in?
2.
It's in quadrant 2. Somewhere over here. What would the reference angle be for 120?
30.
Yeah. What is it? 60 degrees. Again, it's always made with the x-axis, right? So if this is 120, okay, if I go all the way to the blue line, that's 180, right? That means that my reference angle is 60 degrees. Okay, I just take 180, subtract 120 to get to 60 degrees. Okay? Which quadrant is 266 in? Quadrant 3. Somewhere down there, right? So it starts here and it goes all the way around to there to get to 266. 4 degrees shy of 270. We okay? Any questions about this so far?
So then the reference angle for that would be 86.
How would I find it? How about that? You tell me how to find it.
So you would subtract that from 180 right there, wouldn't it? From that line, the 180 line.
Say it the other way. You're doing it backwards.
You subtract 180 from that.
Yes.
It
That's
would
right.
be
To
80.
get my reference angle here, get the reference angle here, I would take my 266 and I would subtract 180 in that case.
So it'd be 86, right?
Right? Okay? So it would be 86. Okay so far? We're filling this in our book. This is in your book, so if you want to, in your examples, remember to fill them in. Alright, any questions about this? Because we're going to hit the triangles running here, and this is huge for grade 12. We okay? Alright. First things first. We studied right triangles since grade 10, maybe even grade 9. So what I need you to do right now is we're going to basically make a little chart. We're going to make a little chart, okay? So the chart's going to look like this. Okay, so put that little chart down in your books. And what we're about to do is we are going to identify the ratios. Now, when you use trigonometry, I'll talk to you as you write down. When you're doing trigonometry, to find the sine of an angle, the cos of an angle, the tan of an angle, you're comparing the ratio of the sides that are involved. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Those are the trig ratios that are involved. So what we're going to do right now is we are going to find those ratios without having to use a calculator. But in order to do that, you have to remember the most important ratio that you are going to remember for 2 years. And that is, what is the sine of 30 degrees? It's imperative that we remember this. So what's the sine of 30 degrees? It's a half, right? And the sine is opposite over hypotenuse, agreed? So I'm going to write this in right here. 1 over 2. That's the sine ratio of 30 degrees. 1 over 2. So now what I want to do, I'm going to ignore 45 for right now. That's a whole different triangle. What I want to do right now is I want to focus on my third side. What is the measure of the third side in this? What's the measure of the third side? How would you find it, Rex?
You'd have to square root 2 and subtract 1. Have square root.
Okay, you're on the right track there, right? Okay, that third side, using Pythagoras' theorem, right? So it is 2 squared subtract 1 squared. What's 2 squared? 4. What's 4 subtract 1? We are going to write that as square root 3. Okay? Now these values will never ever change for a 30, a 60, 90 triangle. Okay? So now, what is the cos of 30 degrees then? What's cos again?
Square root 3 over 2.
It is. So what is it? Adjacent over hypotenuse. Side adjacent's root 3. Hypotenuse is 2. This one is root 3 over 2.
Isn't that supposed to be
Oh, that's sine. Yeah, you're right. My bad. Good catch. This is root 3 over 2. Okay? And what's the tangent now? What's the tan ratio? Opposite over adjacent. In this case, what's the opposite side? 1. What's the adjacent side? 1 over root 3. We're not going to rationalize. We know how to, but we're not going to right now. We'll leave it as that. Okay. So there our focus was on the 30-degree triangle. Or the 30-degree angle, not triangle, but angle. Let's focus on the 60-degree angle. What's the sine of 60 degrees now? Root 3 over 2. Good job. Square root 3 over 2. What's the cos of 60 degrees? 1 half. And what's the tan?
root 3 over 3.
That's right. Root 3 over 1. I don't need the 1, but I'll write it anyways. What do you notice about the ratios between 30 and 60?
They're all triangles with the same.
Two of them are the same except for the reciprocal.
Yeah, we just basically switched them. We just switched them. 1 half and root 3 over 2 becomes root 3 over 2 and 1 half. So as long as you can remember the sine of 30 degrees is 1 half, you can always draw this triangle out, find out what that measurement is. We will not use a calculator for this. You just write it as 1 half and root 3 over 2 as your ratio. Okay, so far? Any questions? All right. I cheat a bit on this guy. The next one I'm going to show you okay? 45, 45, 90 triangle. All right? The sides opposite each other are going to be 1. They got to be the same because the angles are the same. So I'll make them 1. What does that make my hypotenuse measure then? Square root 2. Okay. What is the sine of 45 degrees? 1 over square root 2. Now, for our own purposes, because we do this in grade 12, I'm going to rationalize this denominator. So we started this in grade 10. That means I want to get rid of the root 2 on the bottom. So I times the top and the bottom by root 2 over root 2. So I want you to remember the sine of 45 degrees is root 2 over 2. What then is the cos of 45 degrees? Which is? It's the same thing. Root 2 over 2. Your ratios have to be the same for both sine and cos because the angles are the same. They're both 45s. So they stay the same. Quickly, what is the tan now? 1. Opposite? Yeah. Over Jason. 1. That's going to be your foundation. We are going to work more extensively on this in this class. But next year we spend basically 3 topical units on this right here. We do so much work with this. So what does this have to do with this? Or this? Okay? That's what we're leading to. How do I take those triangles and make it make sense here? So I tend to go outside of the book for a bit because I try to make it make more sense for you. So I'm going to do that right now. I'm going to go outside the book. This is not in your book, but it's going to allow you to have a much better understanding moving ahead. So here's how this works. When we study this quadrantal axis, we want to be able to find out all of the 30s, the 60s, the 45s, and the 90, all of those measurements around this guy right here. I will end up giving you a sheet we call the unit circle that deals with this. Okay? But what it's allowing us to do is we're going to know this entire circle. We'll know what the values, exact values, meaning with square roots, of a 30, a 45, a 60, or 90 triangle. And then when we get into the end of grade 12 of this unit, we start learning that we can find 15 degrees, and we can find 105 degrees by using some unique principles. But for today, let's just look at the very basics here. So I'm going to start with that. First things first, I'm going to draw what I call the unit circle. The unit circle is a circle around this quadrantal axis in which your origin is the center of the circle and the radius of it is 1. Okay? So what I want you to do, actually, let's start like this. Let's everybody take out a blank piece of paper. We're going to do a rough sketch of what I'm about to show you. This is not in your book. I need you to draw it big on a full-size piece of paper. Okay? So make it large because there's going to be a lot of numbers that go on to this. And then we are going to go a little ways ahead of what we need to, and then I'll bring it back to what actually has to be done for today. Okay? So I want you to draw this. So I want to do look like it's lined up. That's better, isn't it?
It's too far out.
Okay. So that's what I need you to start by drawing. Right there. Okay? I'm going to give you a lot of information here in the next 20 minutes. all right? But it's a lot more than what you are going to need until later on in this course and later on into grade 12. Okay? Now, don't draw this in, but I want to show it to you first, this first part here. I'm going to pick a coordinate on the unit circle. So an x and y value on this circle, okay? So I'm going to pick this coordinate right here. I'm going to draw a line through it. So don't draw this on me. So I draw a line there. That coordinate is going to represent all the coordinates around the circle, okay? So that coordinate is x and y. All right? Now I'm going to make myself a little triangle here. So it's a right triangle, right? Well, what's the distance from here to here?
The radius is 1.
Okay, so let's start with that. The radius is 1. But what's the distance from here to there?
1.5 radius.
What's the coordinate? X and y. And x represents what?
The bottom.
How far left or right I go, correct? So what's the distance on the bottom?
Yes.
X. What's the distance right here? Y. Okay? We got that out of the way with. Alright? Again, do not draw this out. I'm just showing you this. Okay? Because we gotta do something else after this. So, now I want you to tell me, what is the sine of angle theta there? Yes, it is. The sine of theta is equal to y over 1. Opposite over hypotenuse. What is the cos of theta? It's correct. X over 1. So far, so good? Okay? And if I wanted it, what would the tan of theta be? Y over x. Okay. So in other words, if I didn't know what x and y were, but I knew what the angle was, I could write it as the ratio of sine theta for y and cos theta for x. That means that instead of xy, I'm going to write cos theta sine theta. So if I didn't know what x was, but I knew I had my triangle drawn, I could write x as whatever the ratio of cos theta was. And if I didn't know what coordinate was, but I knew what y was, it'd be the ratio of sine theta. Okay? I want you to write this in the top right corner of the page I just asked you to draw. So write this, right here, just this, cos theta, sine theta, the top of that page. Okay? Everybody's got that down? Perfect. Now, this big guy. Alright, let's list some coordinates now, okay? Let's list some coordinates around this circle. The first coordinate I want to list is right here. What is that coordinate right there? What is it? Not bad. Okay.
0 and 0? No.
What's the radius of this circle again? 1. So, what's the distance to right here? 1 and how about 0? Right? It's on the axis. So that coordinate's 1 and 0. Write that down. Write that down. 1 and 0. So what would it make this thing then? What would this guy be? 0 and 1. Alright, let's start rolling with this. Over here?
Negative
-1 and 0. And down here,
0, -1.
0, -1. Okay. All right. The next thing I'm going to list now are my angles. I'm going to list my angles now. So what angle is it right here? If my initial arm and my terminal arm are the same thing, what's the angle? 0. Good. 0 degrees. Okay? What about up here? 90 degrees. And over here? 180 degrees. Down here? Very good. 270 degrees. And then if I came back to there, what would it be? 360. So 0 and 360, you would agree with me are the same thing? 0 degrees is 360. Okay, awesome. All right. Okay. How about I tell you this now? What is the cos of 0 degrees? Why? It's just a guess. Yeah. She said the cos of 0 degrees is 1. How come? Where do I find my cos theta on that coordinate? No, on that coordinate. Cos is my x value. Sine is my y value. So what's the sine of 0 degrees? 0. What's the cos of 180 degrees? Brittany? -1. What's the sine of 270 degrees? -1. The sine value will always be the y value of that coordinate. So using the sine ratio, it will be the y value of that coordinate. So now what we're going to do is we're going to use a little bit of work here, and we're going to draw in a bunch more angles on this. Okay? And then I'm going to stop there. I'm only going to work the first quadrant today. Tomorrow we'll come back and we'll do the rest of it. But I'm going to work the first quadrant right now. So now what I'm going to do is I'm going to draw a line. This is what you need to do. Draw a line just like that. And I want that line to be on 30 degrees. So that angle for that line is 30 degrees. I want you to tell me, now, what is the cos of 30 degrees? What is the cos of 30 degrees? Very good. 3 over 2. What's the sine of 30 degrees? 1/2. Okay? What's the cos of 60 degrees? What's the sine of 60 degrees? Those values for every 30-degree angle around the circle, whether it's 120, 150, 210, 240, 300, 330, those values will never change. All that will change is the positive, negative sign depending on the quadrant we're talking about. So if you can remember this right here, if you can remember that, you'll never get it wrong. I can ask you, what's the cos of 120? You might draw it, you might write the coordinate out, and you'll be able to tell me what it is without using a calculator. And it's all based on your reference angle. All based on your reference angle. My reference angle for this guy was 30 degrees. My reference angle for that guy was 60. So we're going to do one more angle right now, and that's this guy. My 45 degree. What's my cos of 45?
2 over 2.
Root 2 over 2. What's the sign of 45?
Root 2 over 2.
Root 2 over 2. Will not, does not change. All based on those two simple triangles I gave you. You could now label this entire circle 120, 135, 150. All the way around the circle, you can label it with those coordinates right there. And you'll know them all.
Will we need to know tan eventually?
Not much, not really. Because with tan, what do we say tan was? What do we say tan ratio was?
Opposite of
Yeah, but I wrote out sine, cos, and tan. It was y over x, right? So all I got to do to get the tan of any one of these is take my y and divide it by my x to do it. So we will get there, but not till grade 12. Are we okay? Two simple triangles. I'm going to ask you to memorize them eventually. You'll get a sheet that has all of these angles on them. But for right now, that's where we got to go to. And we spend oodles of time on that in grade 12. Loads of time on that in grade 12. Very, very important skill for you. Okay? But again, down the road a little bit. We'll come back to this in a day or two. But for right now, I just need you to see that. Okay? Let's do the 3 examples in your book, and then I'm done teaching for the day. Determine the reference angle, theta, or for each angle theta, sketch theta in standard position, and label the reference angle. So 315 degrees. Which quadrant is 315 degrees in?
Third, fourth,
Which one is it?
fourth.
Quadrant 4. So it goes all the way around to right here. So this angle is 315 degrees. What does that make the reference angle right here?
45. Or
135.
not?
135.
You're right again. How'd you get it?
90 degrees. Like, to get to 360?
Yes,
And
that's exactly right. You're 100% correct. The reference angle in this is 45 degrees. How do I know that? Rory said, if I go all the way around, what's the all the way around? 360, but I only went to 315, right? So how do I get it? 360 subtract 45 degrees. Okay, so far? All right? To get my reference angle, I'm going to write this out now. To get my reference angle, no, not yet, not yet. In this quadrant, I find it by taking 180 and subtracting my angle. This one is 180 plus my angle. This one's 360 subtracted. So I'll get to, actually they do write that in here somewhere. Maybe I'll write it out. Oh, they didn't yet. Okay, we'll leave it for another day. All right, now, 201 degrees. Where's 201 degrees? Which quadrant? Quadrant 3. Down here. And how do I get the reference angle? Pardon me? 180 plus. No.
No, it'd be minus.
270 subtracted and
No, because that would give you this angle.
The angle subtract 180.
The 201
Subtract 180.
subtract 180.
Okay.
That's how I get my reference angle. So what is it?
21.
21, isn't it? 21 degrees. Okay? So far, so good? Yes or no? Okay. We're going to do this one more time here. This time, I'm going to give you the reference angle. And I want to find the 3 other angles in standard position that have the same reference angle. So I want one in this quadrant, one in this quadrant, one in this quadrant, right here, And all of the reference angles have to be 35 degrees. So how do I figure out start with the blue. How do I figure out what the angle is in the second quadrant that has a reference angle of 35? No, you're still working with you're working with the verticals. Work with only horizontal. So what do?
Well, you just get 180 subtract 35.
180 subtract 35. Does that get it for me? Yes. So 180 minus your reference angle. That's how I get it in that quadrant. So what is it? 145 degrees. Good. This quadrant, how do I get it?
180 plus 35.
180, add my reference angle. So in this case, what is it? 215 degrees. This quadrant,
360 minus 35.
360 degrees minus my reference angle. I would write that out on that sheet somewhere. Somewhere on that sheet I would write out. Not inside that circle. Put it up in the corner somewhere, bless you, outside your circle. So write that out. 180 minus your reference angle, 180 plus your reference angle, 360 subtract your reference angle. Okay? All right. Any questions? Moving pretty quick. There's lots here. All right. Okay, last question. An 8-meter boom is used to move a bundle of piping from point A to point B. Determine the exact horizontal displacement of the end of the boom when the operator raises it from 30 degrees to 60 degrees. So we want to determine the exact horizontal displacement. So that's little b. Little a, take little a, subtract little b. Alright, so first things first. We need to calculate from this triangle. We're given, so this is, we've done all of this already. We're just going to do it slightly different now. I need to get this guy right here. Alright, so if you're in grade 10, I'd say, okay, well, where is A in relation to 30? Jason? Not yet. No. No, you can't. The right angle triangle. Just wait. Just wait. Just wait. Where is 8 in relation to 30? Hypotenuse. So what are we talking about? Adjacent over hypotenuse, which is? Cos. So on the cos of 30 degrees, I would say, okay, write this out. Cos of 30 degrees equals A over 8. Then you would take out your calculator, right? And you punch it into your calculator. But you're not doing that now. Now I'm using the fact that I know what the cos of 30 is. I'm going to use it. What's the cos of 30? Brittany? Root 3 over 2 equals A over 8.
So you just cross multiply?
So I just multiply the 8 up, right? So that gives me 8 square root 3 over 2 is equal to A. Reduce it. 4 root 3 equals A. So far so good? Okay? So that was my little A distance. What's the problem?
I'm trying to figure it
Okay? So 8 times root
No.
3,
out. Like the 4.
8 divided by 2?
That would be 4 root.
Absolutely not. You can't multiply a whole number with a radical. It just stays as is.
So you can't go like
You can't
4
change
times
it.
2.
No. No. I understand what you're saying. But there's no perfect square that goes into 3. So you don't have to break it down, but you're on the right track. Okay? But we don't have to here. Alright? So there's that. So the second part was want to get b now. So again, which trig function am I using? Cos. Cos of 60 degrees is equal to b over 8. And what's the cos of 60 degrees?
Root 2 over 2.
Only the 45s have root 2 over 2. Cos of 60 is a half. What's b equal? 8 times 1/2, which is 4. Okay? So now they want you to leave the answer as the exact value to get the displacement, what do they call it, from A to B. So the length of AB is equal to the length of A, which is 4 root 3, minus the length of B. And there's your solution. You don't do anything with it, you leave it like that. Don't need to change radicals. Okay? So, that's a little ways ahead. That'll be later on in 3.1. So you're going to, at some point today, you need to get done to the end of question 4 for tomorrow. And then we'll finish up 5 to 9 after tomorrow. But for right now, that took you well in advance of everything that you will need in this section for right now. Okay, so that's a ways down. Tomorrow, the first thing I do is come back and we're going to finish this. That'll be the first thing I do at the start of class tomorrow. We'll finish this off, okay? And then from there, we'll get back into what the book is actually asking you. All right? Okay, so you need to be done to the end of 2.1, question 4 for tomorrow.